In the last video we looked at coordinate geometry and in particular the equation of a circle. Some of the more complicated questions we'll get require some basic understanding of circle theorem. In this video we're going to work through 3 or 4 of the different theorem and look at some of the key features of them. What I've done is designed an app. So we've got a range of different circle theorem here. The first one we're going to look at is this one right here. Angles in a semicircle are 90 degrees. So we can see here I've got a diameter, I've got a chord which crosses the circumference, and we can see that these two chords are perpendicular. So wherever I move this, I have a 90-degree right angle. So angles in a semicircle equal 90 degrees. The second one we're going to look at is now the radius tangent theorem. So here is the radius and here is the tangent. The tangent touches the circle at one point. So some questions you might get will involve the discriminant. b squared minus 4ac will be equal to 0, as now this tangent, or a straight line that we're given, will touch the circle now at one point. We can see that these two lines are perpendicular. So the radius and the tangent are perpendicular. So we'll have now the 90-degree right angle. If we now look at this one, we have now the chord centre theorem. When we have a chord, which is just the line from the circumference to the circumference, a chord is essentially a diameter that doesn't go through the centre. If we have a perpendicular bisector of that chord, it will always go through now the centre. So wherever I go with this, we end up now going through the centre of the circle. So what we can see here is I have two chords that are bisecting now, or two lines that are bisecting these two chords, and they are finding the centre of the circle. So if we have now a chord and we bisect it, the line will go through the centre of the circle. If we look at this one here, we have the dual tangent theorem. So any point that I put out here, we can see now from the point that it touches the circle will be equidistant. So this point to this point will be the same distance as this point to this point. We can use this now to find a range of different lengths. So for example now we have two congruent triangles. If I drew a radius here and a radius here, we could use Pythagoras to work out this length given another length. So if you're given a point outside the circle, you can use the dual tangent theorem to find now missing lengths. So there are 4 of these that are really important for the work that we're going to do. Angles in a semicircle are 90 degrees. We have the radius tangent theorem, so we know a radius just touches the circle at one point. The radius and the tangent are at 90-degree right angles, so they're perpendicular. We know that if we bisect a chord, we will now have a line that goes through the centre, and as we can see, these two lines meet in the middle, and also if we have a point outside the circle, that will be equidistant from the 2 points where now the tangent touches the circle, and we can use basic Pythagoras to find missing lengths. 4 theorem that you should know before we move on with some of the more complicated questions. If you need more work on this, there is a full tutorial on my site.